Speak slower.
Hello. This is a video documenting our project for big data analytics. The project was zip code visualization for housing using the NYC Open Data 311 dataset. My name is Duraif, and presenting this video with me is Peter. Our goal was to visualize zip code suggestions for prospective house hunters using the NYC 311 service requests dataset, which has data from 2010 to the present. The tools that we used were Soda API, Python, Pandas, HTML, CSS, Django, and Folium, which is a visualization library for maps. This is an overview of what we're going to be talking about in this video. So first thing, let's take a look at the data. The 311 dataset has 21.8 million rows and 36 columns, which is too large to utilize raw or analyze locally on your local machine. If you look at the pie chart, you can see that nearly 50% of the rows are not specifically labeled, so there's a ton of pre-processing that's going to be done for this dataset before we can use it for the task of zip code visualization. Now, one question that you need to ask before we proceed is, can this data be used to reliably highlight zip codes for house hunting?
We believe that it can. And the reason we think this is that if you look at the proportion of 311 calls originating from each of New York City's 5 boroughs, you end up with the plot or this graph here that shows that it's roughly correlated to the actual population of each borough. So you can see that 30.8% of New York City's population lives in Brooklyn, and 29.8% of New York City's 311 complaints come from Brooklyn. And a similar level of similarity or correlation is true for all of the different boroughs. Manhattan is actually exactly the same at 19.4% for both population and complaint distribution. So we think that if we normalize the data, it'll give us something that's reliable and reflects the population living in New York. And we run into an interesting challenge as we go forward with our project, which is that we are actually trying to find favorable neighborhoods from complaint data. So we end up with a situation where if there is no data on a particular complaint type in a residential or in a neighborhood, it's kind of suspect to say that that neighborhood is perfect in that way. So, for example, let's say that you are concerned about noise. If a neighborhood has no noise complaints, that could indicate that, yes, that neighborhood's very quiet, but it also could indicate some problem with logging the data. So drawing positive conclusions from negative data poses a very unique challenge for our project. Here's a project flowchart that outlines the way that we got our system working. So as you see, we start with NYC Open Data, which is the place that we're getting our data from, as Duraif talked about. And using the Socrata API, we retrieve a data frame, which is held in Pandas in Python. And this data frame, it's all this raw data, right? And this raw data has some not so great values in it. For example, there are some not applicable areas. There's actually some zip codes that are invalid, that are not applicable. For example, we found some zip codes that were actually from New Jersey, which is not relevant to our project. So you have to filter the data frame using some of Pandas' fantastic tools, as well as Socrata actually. This actually at an earlier stage, there's some filtering as well where you drop not applicable fields. But you filter the data frame using Pandas, and then after you have this data, you use the data to all this Pandas stuff is actually going on inside of Django because it's the framework that is sort of building our website. And so using user input, which is through a form on the web page, it feeds to our data, calls certain things, and then with Folium we visualize the livability of New York based on the user's inputs. And so we end up at the business value. So why is this interesting? Why are we interested in doing this? Well, New York City is a very dense area, and finding a good apartment is a challenge for a lot of people. The 311 data set accurately reflects the livability of neighborhoods in the city through the distribution of recorded complaints. Traditional realtor brokerage websites actually filter properties only by price and amenities, and so we think that we can provide actually an interesting value proposition that would cause users to maybe use our service if we were to develop it further, rather than websites like Zillow, which only give you price and amenities information. And so now we're going to kind of go into our demo, and Durif will take over for that for a second.
Right, so as Peter touched on previously, we're using the Django framework to get our web app working. So how this basically goes is that we create a form class using Django's inbuilt API calls. We're using the criteria. We're using a form, and the three criteria that the user has to input are put into a character field, and which is then passed to the views function, where we're defining the behavior for how the map is visualized. So this function here represents the home page that we'll show you in the demo in a minute or two. And this function here, results, is going to basically capture the data that the user inputs into the form and then pass it on to the function getMap, where we're using the SODA API to fetch the data, filter it according to these three criteria, turn it into a data frame, filter it further using pandas, and then finally using Folium to visualize the map according to these criteria. So now Peter's going to explain to you how exactly that script works.
Yeah, so this is the function that's called by the views file. And you have your imports. You set up a client with Socrata, and we have our app key and password. And with that, then you call the API with your get function here. And this is the part that's kind of interesting. We have this select field, which uses essentially, it's a Socrata specific language, but it's basically just SQL. So we're calling incident zip and complaint type, where the complaint type is one of the three different inputs that the user has put into the form. And then the reason we do that is because like we said, there are dozens of rows and millions of columns. So if we can limit the number of columns and rows that we're calling in the very beginning, we actually significantly reduce the runtime of this specific line of code. Then put it into a data frame. This is just basic pandas stuff. We upload the GeoJSON. Then we're doing some work with zip codes to try to normalize the data. And then down here we're making the map with Folium. You're mapping some data to the actual choropleth map, and then you're saving the map as an HTML file, which is called by our website.
Right. So now that this has been explained, we can move on to the demo itself. Here is how the web page looks. We're giving it a pretty bare bones look, but the functionality is there. So all the user has to do is pick their top three criteria for housing and assign an importance value to them. And after that, all they have to do is click send, after which the web page will render, pull the data, and do all the stuff that we just explained. And then you'd have the output choropleth map popping up, which would look like this. So Folium uses a leaflet.js backend, which is why the map looks familiar to that sort of visualization. And here we have, for noise, the residential areas visualized according to the livability based on the number of noise complaints for those zip codes. Please note that the regions that are dark are because they have no incidents reported. And this is basically how the visualization works.
Yeah.
So thank you for watching our video. We hope it was instructive and interesting. Thank you.